So, hello guys, how are you all doing? I hope you guys are doing well. And in this video, we are going to discuss about the problem number 112. It is path sum. So, what is the actual thing we need to find out in this problem? So, this is an binary tree. So, basically, we have given a binary tree. We need to find out in any of the path of the binary tree we have the target. If we find out the target with the total path, then we can return that as true, or else or we need to return it as false. So basically I will explain it in a detailed way. So if we consider this is a path, these are some paths of binary tree. So in this type we have, so it has some values like 1 comma 2 comma 3 4 5 8 9 and 10. So here if our value should be targeted value should be, so if our targeted value should be we can take like 18. If we achieve any target which is equals to the which is equals to 18, then we need to return it as true. So is there any chance we can find our target is 19 with either of any of the path? So if I mean path, then I need to start from my starting route to the end of the route. So this would be a path, or else this would be a path, or else this would be a path, or else this would be a path. Because if our last leaf of the node, if it does not have any other values here, so we can consider this is the last value or last leaf node present here. So then we can say that this is the last place where our one of the paths will be ended. So as I said, wait a second. So here this would be a path because here left and right are null. So when our left and right equals to null, then we need to check if our target is, so if our target is present or not. So this would be a base condition. So this is an exit condition, exit finding out condition. Okay, exit finding out is the last condition we need to check. But what is the base condition we need to check? While we start iterating through our tree node, we need to first mainly check if our checking tree node, if our checking tree root is equal to null or not. So if our root is null, then we can't check our root dot left and root dot right, root dot left and root dot right. So you guys understood what I'm trying to say. So for example, if this is the tree node here, this is the tree which consists of some values in here. So if we need to check from the starting, if our root is null, like there is nothing here, there is nothing here. Then what we can check here? Nothing we can check because our root is null. Here our root is located here, so this is the root node. For every checking or solving problem in a tree, we need to have a root here. So we will start from the root itself. So we need to have the root to find the solution or any path sum or anything. For that we need this. So the root equals to null will be the base condition to check. If root is not null only, we can check either root dot left or root dot right. Okay, or else we can't check, because if our root is null, how can we check our root dot left or root dot right? If our root is null, how can we check left or right? It's already null, so this would be also null. So there would be an possibility of getting our things complicated and making false information about procedure in the procedural base, because this would be an wrong practice of doing solutions. So we need to use base conditions are very important for the solutions. So without base condition, we will run our loop, run our function wrong, and it will be complicated for us when we do some of the base conditions of it, or some of the types of input characters like empty, like an empty root. We can't have anything to do, right? Okay, yes, this will be our base condition. If we achieve the base condition, we need to return. That's it. We just need to return. So now we will move on to the code. So okay, before going to the code, we can check if our root is present. Then what we need to do? We need to check our root dot left is present or not, and we need to also check for root dot right. What I will do? I will move my root dot left and my root dot left, and I will check if root dot left is present or not. No, here not present. So then what I can do? I will make a sum here, integer sum, and I will minus the values present in it. Like if this is the a path, then what I would do? I would do for every recursive call, I would do root dot value target minus root dot value. I will do target minus root dot value, and I will check. And whenever I hit a condition, like if my root dot left and root dot right is null, then I will check. If I need to check, like I need to do if my sum is equals to 0 or not. I will check that. If my sum is equals to 0, then what I can do? I can return that as 0, as true, sorry, as true. So we will go to the code and do the code. So here in this, I won't do anything. I would just return what we need in this in the target sum. I will take an integer sum here. Integer sum is target sum minus root dot var. I can say root dot var. First we need to start with our base condition. What is the base condition? If our root equals to null, then what we can do? We can return it as null. Then we can return. There is no type of return here. Return value is correctly, so we can just return itself. So if it is present, we will remove it from this, and what we can do? We can move to left and right. So I will return it in the recursive way. So what I can do here, has path sum, I need to call the left and right. So by again taking another extra variable, I can reassign it to the target sum itself. So reassigning to target sum is also a good thing to check here, because if our target sum is 0 or something, so what we can do, we can say we have achieved the target sum. If you are removing something from the target value and we get the value as 0, then we can say we have reached the target sum, because we have a is 100 and we move from a place to a b place, and if our a value becomes 0, then that is the equal value we have went through. So that is the basic thing to observe here. So for every recursive call, I need to keep track of the target sum. So I also need to check. So here I think we should keep and or. Here what we need to check, if our root dot value, root dot left and root dot right is null, then we can check for the target sum is 0 or not. We can check the target sum is equals to 0 or not direct here itself. We can keep in that. If it is equal to 0, it will return true. If it is not equal to 0, it will return the false. So this will check for every recursive call, and I hope this would work. I think here is or we should keep our and. I will try to submit this and we can check for them. So here we need to return some value or something. Sorry, we need to return false here. So we have some issues here. So actually we got accepted. We will try to submit this and check. We have done the spelling mistakes here. The logic is correct. So yes guys, we got this correct. Either any of these should be true, because the two paths should not be cannot be true, because any we can't check, we can't know. There is no guarantee that this all contains the target value and all this also contains the target value. So we need to check either this one or this one or anything. We need to check and we need to operate the sum, target sum, and move our target sum, change our target sum, and update our target sum, and we need to again reassign it to the recursive call target sum with our root dot left or root dot right, either. So I hope you guys understood this. This is a basic tree question you guys should understand. So that's it to this video guys. Thank you.